All right, so this video will focus on 10.6. And the first thing we're going to do is it says you flip a coin and a number and roll a number cube. Find the probability of an event. So flipping a heads, which is a 1 out of 2, right? And then rolling a 6 is a 1 out of 6. So I basically have a 1 out of 12 chance of doing this, theoretically. Flipping a heads and rolling an odd number. Well, that'd be a 1/2 again, times 3/6, which is 3 over 12, or 1/4. Flipping a heads and rolling a number greater than 3. Well, numbers greater than 3 are 4, 5, and 6. So I have a 3 out of 6 chance again, and a 1 out of 2 chance of getting a head. So this again is 3 out of 12, or 1/4. And then finally, flipping a tails and rolling a number less than 5. Well, less than 5 would be 4, 3, 2, or 1. So that's 4 out of 6 times 1/2. And that would be 4 out of 12, or 1/3. So if I look here, I have my 1/12, my 1/4, my 1/4, and my 1/3. And that's how you figure these things out. But what we want to figure out today is about population surveys and see if they represent the population themselves. So I want you to take a moment and look at these 4 examples, and I want to figure out what's the population and what is the sample. Well, the population for A is the students in a school, and then the students in a math class might be the sample of the whole school, right? This is the larger, this is the smaller. For the grizzly bears in the park, just the ones that GPS trackers or whatever will be the sample of the larger population. So the sample is always smaller than the population. If I have all the quarters in circulation, that's my population, and the quarters are the sample. And then finally, all the books in the library versus 10 nonfiction books or 10 fiction books. This here is the sample, this here is the population. Now, what we're basically trying to do today is figure out, if I look at different studies, if they are accurate or not, or if they're biased. So the first thing, for instance, it says a local radio show takes calls from 500 residents, and the table shows the results of the radio station concludes that most of the residents of the town oppose the new power plant because there's 74, a lot against, and some that don't know. Now, is this representative of the entire city? Well, we don't really know in this case if it's representative, but it's a pretty big number of residents. We don't know where they called from. There's a bunch of things that we don't know, like do they live right next to where the power plant is going? So we have to probably figure that out. But it does seem like it might be valid. There's a number of residents here, a lot of them. 500 is a big number. A number of reporters randomly, or a news reporter randomly surveys 2 residents outside the supermarket. Just 2 people, and they ask about the power plant. It says one is for and one is against. Well, that's only 2 people. I probably need more than 2 people to do it, so this is not valid. And it says you randomly survey 250 residents at a shopping mall. The table shows the results, and that there are twice as many residents in town against the new power plant as for the new. Well, here's the thing again, 250 is a lot, and I like that. I think that's great. The problem, though, is we don't know where these people live in relation to the power plant. If a lot of these people live at this shopping mall is located right next to the power plant, they might not want it. So we have to know more information. But again, 250 people is a lot of people to survey. So what we're going to do next is look at this here and figure out the population in the sample. So I have a residents of the city and the senior residents of the city. And I want you to pause the video and try to figure out which is the population and which is the sample. All right, so you should have had a chance to do that. The residents of the city is the population, and this is the sample. The members of a gym who play basketball is the sample, and the members of the gym are the population. The books in the classroom and nonfiction books in the classroom. The books in the classroom are the population, and this is the sample. And then travel mugs in a souvenir shop and mugs in a souvenir shop. The mugs in the souvenir shop would be the population, and the smaller part is the sample. So then let's look at this here. And it says you want to estimate the number of students in a high school who ride the school bus. Which sample is unbiased? Just 4 students in the hallway? All students in the marching band? 50 seniors at random? 100 students at random during lunch? Well, here's the thing. 4 is not enough. The marching band might work, but we don't really know if there might be a lot of people like seniors or people that drive in this marching band. 50 seniors would be a terrible thing because that'd be very biased because they might all have cars and they might not drive or take a school bus to school. But 100 students at random during lunch might be a good thing. So let's look here. So this is D. This is probably the best one that would be unbiased. So what if you want to estimate the number of seniors in a high school who ride the bus? Which sample is unbiased? If I go back up here, probably 50 seniors at random would be really good. Another one, you want to estimate the number of 8th grade students in your school who consider relaxing to listen to music. You randomly survey 15 members of the band. Your friend surveys every 5th student whose name appears in alphabetical order list of 8th graders. Which is unbiased? Well, probably not the band one because they probably like music, right? So, and there's only 15 of them. I like the one where it's every 5th student. That's pretty random. So here are the two. All right, so this one here says you want to know how the residents of your town feel about adding a new stop sign. Determine the number, or determine whether each conclusion is valid. So you surveyed 20 students who live closest to the new sign. 15 support the sign, 5 do not. So you conclude that 75% of the residents of your town support the new sign. Well, again, they live really close to it, so they really care about it. People that live further away probably don't really see a need as much, and they don't care. You survey 100 residents at random. 40% the new sign, 60 do not. So you conclude that 40% of the new residents of your town support the new sign. This is probably more accurate. This one here says you ask 75 random chosen students how many movies they watch each week. And there are 1,200 students in the school. Predict the number of N students in the school who watch one movie each week. So if I go to one movie each week, I know that there are 21 out of 70 from my smaller survey, right? The population, because there's, 75, sorry. So 21 over 75. And then I know that there are a total of 1,200 students. If this is representative of the whole, I should be able to cross multiply and get 75x equals, what would that be? 12,000, or I'm sorry, 24,000, and then, so I'll do 24,000, because that's times 2, and then 1 times this is 1,200. So I have 0, 0, 2, 5, 2. So I have 25,200 equals 25,200. Let's figure this out because I don't know that offhand. So if I take 25,200 divided by 75, I get about 336 kids. And that's what they get here too. And then finally, here's this one. In example 2, each of the 25 randomly chosen firefighters supports the new sign. So you conclude that 100% of the residents of your town support the new sign. Well, they're firefighters, so they care about safety more. So they're going to want the sign probably. And then in example 3, predict the number of students in the school who would watch 2 or more movies per week. So I do the same thing that I did here. But instead I have 24 over 75. And the other one is 1,200. I know again that this number here, well, 24 would be a bigger number, wouldn't it? So I basically have to add 3,600 more to this number. And you can just, I mean, all that I'm doing just so you know is you can take 24 times 1,200 and get the same answer I'm going to get. 0, 0, 8, 8, 2. So 28,800. So I'd have 75x equals 28,800, which is what 1,200 times 24 is. All right. So I'm going to go back and do this on the side. Let's just quickly make sure my math was right. 24 times 1,200. 28,800, good. And I'm divided by 75, and that equals 384. So this should be 384 for this one, and this is, it's biased because they're all firemen. So, and 384. So that is really the lesson today.